All right, let's talk about the mole and molar mass. Now, you can't talk about the mole without talking about Avogadro's number. And Avogadro's number is kind of talked about as being the chemist's dozen. So, what I mean by that is when I say I have a dozen cookies, everyone knows that I have 12 cookies. With Avogadro's number, when we talk about Avogadro's number, everyone knows we have that many cookies. So, what it does is it relates the mass of an element or a compound to the number of molecules that are present. And Avogadro's number is 6.022 times 10 to the 23rd. Notice that I don't put any units on that. Just like you don't put units on a dozen. It can be anything you want it to be. I could have a mole of M&Ms, which means I would have 6.022 times 10 to the 23rd mole moles of or just M&Ms. That would be so many M&Ms and I could probably swim in them. Anyways, so this is equal to 1 mole. Now, the mass of 1 mole of any substance, it can be an element or a compound, this is called the molar mass. And sometimes that will be abbreviated as a capital M. Now, you determine the molar mass by expressing the atomic mass from the periodic table in grams per mole. So those units would just be grams over moles. And realize that when we're writing these units out and they're being typed out, it's more common to see them written as grams per mole like this. But what you need to remember is the grams are in the top and the moles are on the bottom. So let's get some practice with calculating the molar mass of a compound. You're going to need a periodic table. So if you don't have a periodic table near you, go ahead and grab one. So to calculate the molar mass of the compound, like we said, add the mass of each atom found in the compound from the periodic table and add them up. So if we look at PbO2, look, I have 1 lead and 2 oxygen. So I'm going to look at the periodic table and find the atomic mass of lead, which is 207.2, and I'm going to put the units of grams per mole with it. Now I can go look at the periodic table for oxygen, 15.999. And since I have two of them, I'm going to multiply it by 2. And then I add those two together to get the molar mass of my PbO2. Now, when you are calculating the molar masses of these different compounds, it's totally fine with me if you just use two places past the decimal point when you do your calculations. So let's do this example down here. We want to calculate the molar mass of carbon dioxide, CO2. So I'm going to look at my periodic table. I'm going to find carbon, and I see the mass of carbon is 12.01 grams per mole. How many carbon do I have in my compound? I have 1. So I am just going to leave it as 12.01. And then I'm going to add that to the mass of my oxygen. Now, if I look at my periodic table, the mass of my oxygen is 16.00 grams per mole. Now, some of you might be thinking, wait, we just did this and the molar mass was different in the above example. Well, it really isn't. 15.999 is essentially 16.00, just rounded to 2 places past the decimal point. So I can take this and I'm going to multiply it by 2 because I have 2 oxygens in carbon dioxide. So go ahead and do that math. And what do you all get? Yep, I get 44.01 grams per mole as well. Well, guess what? What can we use this as? You got it, a conversion factor, because I can write this as 44.01 grams of CO2 per mole of CO2. So the molar mass is a great way to convert between moles and grams of a substance. Now, the reason moles are so great is because if we look at this image here, it looks like we have approximately the same amount, right? Don't these heaps of stuff look the same? But if you look at the masses, they're all different, right? So this is the amount of 1 mole of each one of these substances. So we have 1 mole here, 1 mole here, 1 mole here, and 1 mole here. So when we're talking about moles of substances, we can compare two different substances. We cannot compare the mass of two different substances because you see, each one of these moles has a different mass. So I can't compare the mass of iodine with the mass of sulfur because they're not equal. However, this is 1 mole of iodine and 1 mole of sulfur. So let's get some practice with calculating or using the molar mass as a conversion factor to convert between grams and moles. Now I'm going to set this up just like all of my conversion factor problems. I'm going to state my given. It is the only number in my problem, so that is going to be my given. I have 30 grams of water. I'm going to find my need. It's going to be present in the question or a bossy statement. It says, how many moles? So I'm going to calculate my moles of water. When I look at this, I have grams and I need moles. So that tells me I'm going to have to use the molar mass of water. Now, in order to get my conversion factor for this type of problem, I'm going to have to calculate it. So I need to calculate the molar mass of water. Now, in water, I have hydrogen, and the molar mass of hydrogen is 1.01. And I have two hydrogens in my water. And then I can find oxygen, 16.00 grams per mole, and I only have one of those. So I'm going to take my 1.01 times 2, and then I'm going to add that to my 16.00 to give me 18.02 grams per mole. So the molar mass of water is 18.02 grams per mole, and that is the conversion factor that I'm going to use. Because realize that the 18.02 grams per mole is also an equality. 18.02 grams of water is equal to 1 mole of water. So I can start my problem. I'm going to start with my 30 grams of water. And I'm going to use my equality, use my conversion factor to solve for this. Now, when I put this in as my conversion factor, remember we have to have grams on the bottom. So I can see that the 18.02 goes with the grams. So I'm going to write that down here. And then I can put my moles on the top. So now my grams cancel and I'm left with moles, which is good because my need is moles. So we can go ahead and calculate this by taking 30 and dividing it by 18.02. And when I plug this into my calculator, I get 1.67 moles of H2O. So go ahead and try the following calculation. It's working in the reverse direction. How many grams are in 2.7 moles of water? Go ahead and pause the video. When you get your answer, come back and you can check your answer. All right, let's look at this. My given is now 2.75 moles H2O, and my need is grams of H2O. Notice we're still going between moles and grams, and I'm still going to use my molar mass. This is nice because I don't have to calculate a new molar mass. I can use the one I already calculated from the previous problem. So I'm going to start with my given, 2.75 moles of water, and then I'm going to use my molar mass to convert into grams. So here I have to have moles on the bottom. So I'm going to write my conversion factor as 18.02 grams per mole. My moles cancel out. I'm left with units of grams, which is good because that's what I need. And I can plug this into my calculator. And now I'm going to multiply 2.75 by 18.02. And when I do that, I get 49.5 grams of water.